Hello, eighth grade. We are in week 16, and it happens to be the last week of the year 2020 for our school year. We're going to be talking about electromagnetic waves. And in this first lesson, we want to be able to explain the basic properties of electromagnetic waves. So, what do these two photos have in common? Well, they both represent electromagnetic waves. These are waves that consist of vibrating electric and magnetic fields. They transmit energy through matter or across space. Some electromagnetic waves are generally harmless. The light we use to see is one good example. Other electromagnetic waves can be very harmful, and care must be taken to avoid too much exposure to them. X-rays are a familiar example. Why do electromagnetic waves vary in these ways? It depends on their properties. Like other waves, electromagnetic waves have properties of speed, wavelength, and frequency. All electromagnetic waves travel at the same speed through empty space. That speed, called the speed of light, is about 300 million meters per second, 299,792 kilometers per second, to be exact. Nothing else in the universe is known to travel this fast. The sun is about 150 million kilometers, or 93 million miles, from the Earth. But it takes electromagnetic radiation only 8 minutes to reach the Earth from the sun. If you could move that fast, you would be able to travel around the Earth 7.5 times in just 1 second. For light to travel from the Earth to the Moon, it takes 1.3 light seconds. From the Earth to the Sun, 8 light minutes. From the Earth to Mars, 12.7 light minutes. So we're actually closer to the Sun than we are to Mars. Earth to Alpha Centauri, 4.4 light years. That's the closest star outside of our own sun. And Earth to the far side of our Milky Way galaxy, in other words, if we were to cross from where we are on one edge of the galaxy to the other edge of the galaxy, it would take 52,000 light years, or 52,000 years traveling at the speed of light. But we've often thought about traveling at the speed of light, and there are many, many, many science fiction stories talking about traveling at or beyond the speed of light. And this, ladies and gentlemen, is what happens when someone leaves the window open. Okay, sorry, had to just throw that in there. Although all electromagnetic waves travel at the same speed across space, they may differ in their wavelengths, frequencies, and energy levels. Wavelength is the distance between corresponding points of adjacent waves. Wavelengths of electromagnetic waves range from longer than a soccer field to shorter than the diameter of an atom. Wave frequency is the number of waves that pass a fixed point in a given amount of time. Frequencies of electromagnetic waves range from thousands of waves per second to trillions of waves per second. The energy of an electromagnetic wave depends on their frequency. Low frequency waves have little energy and are normally harmless. High frequency waves have a lot of energy and are potentially very harmful. So, which electromagnetic waves do you think have higher frequencies? Visible light or X-rays? Well, to be honest, which one is more harmful? X-rays are harmful, but visible light is harmless. So you can infer that X-rays have higher frequencies than visible light. The speed of a wave is produced as a product of its wavelength and frequency. Because all electromagnetic waves travel at the same speed through space, A wave with a shorter wavelength must have a higher frequency, and vice versa. This represents a relationship in this equation. Speed equals wavelength times frequency. The equation for wave speed can be rewritten as frequency equals speed times wavelength, or wavelength equals speed times frequency. Therefore, if either wavelength or frequency is known, the missing value can be calculated. Consider an electromagnetic wave that has a wavelength of 3 meters. Its speed, like the speed of all electromagnetic waves, is 3.0 times 10 to the 8th meters per second. Its frequency can be found by substituting these values into the frequency equation. Therefore, frequency equals 3.0 times 10 to the 8th meters per second times 3.0 meters, which was the wavelength that was given in the problem. That equals 1 times 10 to the 8th waves per second, or 1 times 10 to the 8th. Do you remember? What unit do we use? That's right, hertz. 1 times 10 to the 8th hertz. So, question, what is the wavelength of an electromagnetic wave that has a frequency of 3 times 10 to the 8th hertz? Well, to find that, we have to figure out the wavelength. Wavelength equals 3.0 times 10 to the 8th meters per second times 3.0 times 10 to the 8th waves per second that would equal 1 meter. So in summary, all electromagnetic waves travel across space at the speed of light, which is about 300 million meters per second, or 3 times 10 to the 8th meters per second. Electromagnetic waves vary in wavelength and frequency. Longer wavelength electromagnetic waves have lower frequencies, and shorter wavelength waves have higher frequencies. Higher frequency waves have more energy. Likewise, lower frequency waves have less energy. The speed of a wave is a product of its wavelength and frequency. Because the speed of electromagnetic waves through space is constant, the wavelength or frequency of an electromagnetic wave can be calculated if the other value is known. So, if you feel that you can explain the basic properties of electromagnetic waves, feel free to move on to the questions. But if you would like to look at this video one more time, write down some notes, and prepare yourself a little bit more, that would be an awesome idea, because chances are you're not going to be able to come back to this video once you click into the questions. Either way, hope you have a great day, and we'll talk to you again later. Bye-bye.